Hey, it's Zoe from Seneca, and today we're going to be looking at polar covalent bonds. So, some bonds within molecules may be described as polar. This is caused by differences in electronegativities. In a bond between two unlike atoms, one atom will have a stronger attraction to the electron pair than the other. This means the electron pair will not be at the center of the bond. This causes the build-up of a partial charge on one atom. This is usually written as delta plus or minus. The ability of an atom to attract the electron pair is called electronegativity. The values of electronegativity can be measured on several different scales. The one you need to know about is called the Pauling scale, named after Linus Pauling, its inventor. Great guy. The most electronegative element is fluorine with a value of 4.0. Other strongly electronegative elements are oxygen, which is 3.4, chlorine, 3.2, and nitrogen, 3. Carbon has an electronegativity of 2.5 and hydrogen has an electronegativity of 2.2. The most electronegative atom in a bond will develop a partial negative charge, delta minus, and vice versa. This charge difference is called a permanent dipole. A good example of a polar bond is the HCl molecule. A good example of a non-polar bond is the CH bond. The electronegativities of hydrogen and carbon are very similar, so the bond is not polar. Electronegativity is the ability of an atom to attract a pair of electrons. Okay, moving on to polar molecules. Molecules can have an overall dipole just like bonds. A requirement for a molecule to be polar is that it has polar bonds. If there is a charge separation between one side of the molecule and the other, there will be a permanent dipole. A good example of a molecule like this is chloroform, which has the formula CHCl3. A molecule with polar bonds is not necessarily polar. If the bonds are arranged symmetrically around the center, then the partial charges will be the same on each side of the molecule. Such a molecule is not polar. A good example of a molecule like this is tetrachloromethane, CCl4. The elements have been scaled in terms of their electronegativity by using the Pauling scale. Okay, a molecule contains multiple polar CCl bonds. Is the molecule definitely polar? What's the answer? No, because the polar bonds may cancel each other out. Nice video, not going to watch it. Which of the following is not a polar molecule? CH3Br, probably could be. H2O, yes. CCl4? Nope, because the delta minuses cancel each other out because they're on the outside of the molecule, therefore it's not a polar molecule. Okay, that's all for today. Thanks so much for joining, and we'll see you on the next episode. Goodbye!